This summer, Earth is spinning faster than usual. On July 10th, it completed one full rotation in 1.36 milliseconds, less than 24 hours, according to data collected by the International Earth Rotation Well. Though a full rotation of Earth lasts 86,400 seconds or 24 hours on average, in reality, each rotation is slightly irregular. The gravitational pull of the Moon, seasonal changes in the atmosphere, and the influence of Earth's liquid core all contribute to these discrepancies. As a result, a full rotation usually takes slightly less or slightly more than 86,400 seconds. The shortest-term changes in Earth's rotation, Agnew said, come from the Moon and the tides, which make it spin slower when the satellite is over the equator and faster when it's at higher or lower altitudes. This effect compounds with the fact that during the summer Earth naturally spins faster, the result of the atmosphere itself slowing down due to seasonal changes, such as the jet stream moving north or south. The laws of physics dictate that the overall angular momentum of Earth and its atmosphere must remain constant, so the rotation speed lost by the atmosphere is picked up by the planet itself. Similarly, for the past 50 years, Earth's liquid core has also been slowing down with the solid Earth around. It's speeding up. The moment at the turn of the last century when the world thought a kind of doomsday would ensue, because computers might have been unable to negotiate the new date format, going from 99 to 00. And that's okay most of the time. These milliseconds don't have any obvious effect on everyday life. To build their model, the researchers considered the mass and gravitational pull of Earth, the Moon, and other nearby objects such as satellites. Then they factored in the movement of these bodies plus the melting of ice caps, the redistribution of water, and the exchange of mass and momentum between Earth's surface and its core. They found that by the end of this century, in a pessimistic scenario, in which humans continue to emit more greenhouse gases, the effect of climate change could surpass the effect of the Moon, which has been really driving Earth's rotation for the past few billions of years. We're really in a unique period where the impact of climate change is larger than the astronomical effect, Soja said. And I think this is maybe worth pointing out because it shows that we are really changing the planet in many ways. Melting ice is also a contributing factor to the issue of the leap second, but in a surprising way. I think the faster spinning is still within reasonable boundaries, so it could be natural variability, Soja said. Maybe in a few years, we could see again a different situation, and long-term, we could see the planet slowing down again. That would be my intuition, but you never know. Meltwater from Greenland and Antarctica ice sheets is responsible for a third of the global sea level rise since 1993, according to NASA. However, the effect of this phenomenon is unlikely to outweigh the contribution of other factors soon. According to the current projections, Earth will continue spinning faster until at least 2040. After that, we may experience a slowdown, but it's impossible to tell. Long-term, we could see the planet slowing down again, said Benedict Soja, an assistant professor at the Department of Civil, Environmental and Geomatic Engineering of the Swiss Federal Institute of Technology in Zurich, Switzerland. At the moment, potentially having more time to prepare for action is helpful, given the uncertainty of long-term predictions on Earth's spinning behavior. While global warming has had considerable negative impacts on Earth, when it comes to our timekeeping, it has served to counteract the forces that are speeding up Earth's spin. A study published last year by Agnew in the journal Nature details how ice melting in Antarctica and Greenland is spreading over the oceans, slowing down Earth's rotation, much like a skater spinning with their arms over their head, but spinning slower if the arms are tucked along the body. These fluctuations have short-period correlations, which means that if Earth is speeding up on one day, it tends to be speeding up the next day, said Judah Levine, a physicist and a fellow of the National Institute of Standards and Technology in the Time and Frequency Division. But that correlation disappears as you go to longer and longer intervals. And when you get to a year, the prediction becomes quite uncertain. In fact, the International Earth Rotation and Reference Systems Service doesn't predict further in advance than a year, and Reference Systems Service and the U.S. Naval Observatory, and compiled by Live Science. When the leap second system was defined in 1972, Nobody ever really thought that the negative second would ever happen, he noted. Everybody assumed that only positive leap seconds would ever be needed. But now the shortening of the days makes negative leap seconds in danger of happening, so to speak. That's why even the smallest time deviations are tracked using atomic clocks, which were introduced in 1955. There are still places that do it wrong or do it at the wrong time or do it with the wrong number, and so on. And so, with a positive leap second, there are occasionally problems. But with a negative leap second, there is real danger of catastrophe, at least for a small number of systems that are affected. But there are fluctuations. It's like watching the stock market, really. There are long-term trends, and then there are peaks and falls. In 1972, after decades of rotating relatively slowly, Earth's spin had accumulated such a delay relative to atomic time that the International Earth Rotation and Reference Systems Service mandated the addition of a leap second to the UTC. This is similar to the leap year, which adds an extra day to February every 4 years, to account for the discrepancy between the Gregorian calendar and the time it takes Earth to complete one orbit around the Sun. Since 1972, a total of 27 leap seconds have been added to the UTC, but the rate of addition has increasingly slowed due to Earth speeding up. 9 leap seconds were added throughout the 1970s, while no new leap seconds have been added since 2016. In 2022, the General Conference on Weights and Measures (CGPM) voted to retire the leap second by 2035, meaning we may never see another one added to the clocks. But if Earth keeps spinning faster for several more years, according to Agnew, eventually 1 second might need to be removed from the UTC. There's never been a negative leap second, he said, but the probability of having one between now and 2035 is about 40%. They count the oscillations of atoms held in a vacuum chamber within the clock itself to calculate 24 hours to the utmost degree of precision. We call the resulting time UTC, or Coordinated Universal Time, which is the global standard for timekeeping as well as the time to which all our phones and computers are set. Astronomers also keep track of Earth's rotation using satellites that check the position of the planet relative to fixed stars, for example. They can detect minute differences between the atomic clock's time and the amount of time it actually takes Earth to complete a full rotation. Last year on July 5, 2019, Earth experienced the shortest day ever recorded since the advent of the atomic clock 65 years ago, at 1.66 milliseconds less than 24 hours. Even more exceptionally short days are coming on July 22nd and August 5th, currently predicted to be 1.34 and 1.25 milliseconds shorter than 24 hours, respectively. Now, you might say, who cares? A day is a day, right? However, these discrepancies can in the long run affect computers, satellites, and telecommunications. We've been on a trend towards slightly faster days since 1972, said Duncan Agnew, a professor emeritus of geophysics at the Scripps Institution of Oceanography and a research geophysicist at the University of California, San Diego. What is causing Earth to spin faster? By looking at the combination of these effects, scientists can predict if an upcoming day could be particularly short. While one short day doesn't make any difference, Levine said, the recent trend of shorter days is increasing the possibility of a negative leap second. The prospect of a negative leap second raises concerns because there are still ongoing problems with positive leap seconds after 50 years, explained Levine, because so many fundamental technologies rely on clocks and time to function, such as telecommunications, financial transactions, electric grids, and GPS satellites, just to name a few. The advent of the negative leap second is, according to Levine, somewhat akin to the Y2K problem. But one factor might help us avoid a doomsday scenario this time: climate change. If that ice had not melted, if we had not had global warming, then we would already be having a negative leap second, or we would be very close to having it, Agnew said. Soja and his team recently published a paper showing how they used a computer model to simulate Earth's rotation over the past 3 decades and estimate its future behavior for the next 10,000 years. At the moment, Earth is spinning about 1 millisecond faster than it would have otherwise, Soja said, but that could change dramatically.